The next thing we'll talk about in continuing our discussion on the applications of cryptography are digital signatures. Now, digital signatures are basically used to help ensure non-repudiation. Now, let's look at some definitions. If a user, or anyone for that matter, can deny that they took an action, that's called to repudiate it. They're denying it. Non-repudiation means that the action cannot be denied. There's no way, because they're proof that they actually did it. So non-deniability and non-repudiation are the same thing. Now, how can digital signatures assure non-repudiation? Well, if we have a public and private key, and the individual has the private key and no one else has it and is able to use it, and then they use it, then we know that it only came from them, and so they can't deny that they did it. Now, if they assert that someone has stolen their private key, then we've got a bunch of different other problems. Non-repudiation is provided by the use of digital signatures, of course, and if we have a digitally signed email, for example, it proves that only the sender could have and did actually send that email because it's signed with their private key. The digitally signed document actually authenticates the author or sender of the document to that document. It ties them together. Now, how does this work? Let's say we have a message or a document or whatever. This message is hashed using some of the hashing processes that we've talked about earlier. And we know that if we hash a document, it produces a fixed digest. And later, if that document is hashed again and we get another digest, those two numbers should match. If they match, that means the document has not been altered at all. Now, if even one single bit is flipped, a 1 or a 0, it's changed in that document, the hashes will not match, and that means the document has been altered somehow, possibly intentionally or possibly during transmission. It was corrupted. So you have this hashed document here. Now, how would you digitally sign it? Well, it's simple. You would encrypt that hash value with your private key, and the private key encrypts the hash of the message, and we send this as part of the package. When it gets on the other side to the sender actually has the public key out there for everybody to use, so the recipient takes the sender's public key and decrypts it. Because remember, what one key encrypts, only the other can decrypt. So if it's encrypted with a private key, only the corresponding public key can decrypt it. So the recipient uses the sender's public key to decrypt the hash, and so then they have the hash value. Then they hash it themselves, the document, hashes match, then they know the message has not changed. If the hashes do not match, they know that somewhere along the line the message changed. Now this encrypted hash, this digital signature, is sent separately from the message. In other words, they get the message, and it could be encrypted or non-encrypted, but they also get this encrypted hash also that's been signed with the sender's private key. Now, theoretically, since only the sender possesses that private key, it's considered signed by them and considered to be authentic, assuming that no one has compromised the key. So let's take you through this again using a little bit of a visual aid here. We have the sender on the left-hand side, and they have a document, and they hash that document, and then that hash is encrypted with their private key. It gets sent over, maybe in the same email as the message, maybe in a different email, whatever, and it gets sent over there. Now, anyone can decrypt it, and so confidentiality is not the issue. Anyone can decrypt it and see what the hash is. They may not have the document to compare the hashes with, but anyone can decrypt that. So it's not really assuring confidentiality, it's assuring authentication. So you're decrypting that hash using the public key, and you get that hash value. Then you would hash the document yourself. If the hashes match, then the document has not been altered. If they do not match, then the document intentionally or accidentally has been altered. That's kind of how a digital signature works. Now, this is a very simplified explanation model, and for the exam, you really don't have to know in depth how all of this works. You just need to know it as a good security person, but you may see a question or two on this on the exam, and it may actually relate to other questions. So you're not going to probably get specific questions on how digital signatures work. So that's basic digital signatures, encrypting a hash with a private key, decrypting the hash with a public key, and that tells us that only the person who possessed that private key, the sender, could have sent it. So they can't deny that they sent it because only they have the private key.